anyone who's listening. Yeah, I'm just going to do a wee kind of workshop on ergonomics of VR controllers. So I have a presentation and then some discussion questions that people can either engage with, and we can have a chat, or take them away as questions to think about from the session itself. So yeah, just a bit about me before we start. Yeah, my name's Lewis Urquhart. I'm from Scotland and work at the University of Strathclyde as part of the Prime VR Squared project. So we'll get into some of the details of that just now. So yeah, just a wee introduction. Ergonomics is the study of human psychology and biology for essentially for design applications in the main. And this is a critical element in pretty much all controller design. So there's many different kinds of controllers that exist, each with different requirements and capabilities. I'm sure you've experienced and used lots of different kinds of controller setups in your lives. So like ones are encountered every day, you know, TV controllers, game console controllers, smartphones, and lots of different other kinds of small control interfaces. So often these are designed to be used by a single hand, but others are designed to be optimally used by two hands. So some examples here on the left there, you have one-handed smartphone use, although like some people use two hands on their smartphones as well. In the middle there, television controller. Obviously, most people use that with one hand, and it's essentially designed to be used with one hand. And then on the right there, your PlayStation controllers that are expressly designed to be used with two hands. So I mean, as you can see here, there's different sort of ergonomic challenges with each controller, and different sort of control, different kind of control setups that the designer needs to consider as they go about embodying the control system, control interface. So, for instance, with the smartphone, it's almost quite a free form system. Like there's lots of different things you can do. You can do with it and interact with it in lots and lots of different ways. But the other types of controllers, like the television controller or the PlayStation, is in some ways more limited, because the system it engages with is functions with kind of more strict rules, like you have to press this button to do this in the game. But with a smartphone, there's a bit more I suppose flexibility. So I mean, these are just some of the kind of observations I've made when thinking about this. Yeah, but VR controllers, present new and different complexities, as they essentially remove like a direct visual relationship between the user and the controller itself, because obviously you're wearing the VR headset, so you lose this kind of relationality, and your like sort of spatial relationship, the kind of proprioception between your hand and what you're actually having to do to control your hand in various ways. So and additionally, the game and control motions possible in VR, kind of like a kind of like the example we saw comparing the smartphone to the television remote. Much more complex, presenting challenges for ergonomic design. So people who are very familiar with VR gaming, VR systems will know that the types of motions, the types of movements, the types of controls that are possible in VR kind of transcend what's possible in a conventional gaming space, sort of experientially, especially that kind of thing. It's much more complex, lots more things going on, and so this presents challenges for ergonomic design. So I mean, just to tie this into Prime VR now, so Prime VR Squared is a Horizon 2020 EU-funded project that aims to create bespoke VR gaming controllers to aid medical rehabilitation. So the bespoke controllers will be designed around the individual patient. That's the principle, at least. So this presents unique challenges for ergonomic design, as the requirements for each user can be very, very specific. So the user needs are much more complicated than someone with sort of quote unquote normal capabilities. So in relation to this, Prime VR has developed a unique workflow allowing for capturing of biomechanical data that can then be used to create ergonomic profiles for controller design. So yeah, to capture like ergonomic data, we had to consider many factors. So critically, we had to think about the therapeutic goals, obviously. What do the users need? What do the clinicians want from the controller, from the hardware? And also how exactly would the controller be operated? So subsequently, a data capturing rig was developed that could capture 3D anatomical information of the hand, as well as capture range of motion and forces. And you can see a mock-up there of our prototype. So these three data types would essentially provide a comprehensive set of data from which to build the controller design. So this would be a kind of highly tuned ergonomic design based on this, if you like, of pieces of data. So we have forces that a user is capable of delivering in the hand. So like this data was then fed into our generative design algorithms. These algorithms were developed in a program called Rhino Grasshopper, which provides a lot of flexibility in design, and is able to generate like viable controller forms, utilizing the ergonomic profile that had been captured by the rig mentioned in the last slide. So critically, the data allows for the creation of essentially entirely bespoke geometries tailored around the specific individual. So this is some of the preliminary acquisition data that we captured while we were developing this system. So this one here is not actually a real hand. This is a plaster cast of a hand that we had that we used to develop and refine the system. So as you can see, the boundaries of the forms are well defined, and this data can be fed into the algorithmic workflow. And down here, this is the range of motion capturing. So you can see at the top here on the little picture, the little screen grab, the different motions that should be conducted during the acquisition, if possible. And then here is the skeleton model that provides a distillation of these types of data capture. So it's quite fairly like a fairly comprehensive system that in we're still kind of refining it in some ways. Like fundamentally, it provided provided this bespoke data that could be fed into our design work. So, I mean, these are some of the very initial concepts that we were exploring. So, like these were the configurations that like align to the therapeutic modes that we identified as viable candidates for exploration in the work. So, I mean, these were plausible configurations of our kind of controller, but they weren't attuned. None of them were attuned to specific ergonomic needs of the user. So, I mean, our workflow allowed us to develop these ideas in discrete directions around highly specific biomechanical requirements, as captured by the scanning rig. And I mean, these were just initial ideas that for our controller design that we came up with near the start of the design work. But I mean, they were quite generic, and they were just exploring different forms. But none of them at this point were able to kind of amalgamate with and articulate with direct ergonomic needs. So, I mean, this takes us into some initial scan data that we captured during the project, during the initial design work. So, yeah, the initial scan data is shown here. So that, I mean, this data provides dimensional detailing of the hand, forearm, and elbow. So, yeah, and you can see that this data can be CAD environment as shown here. So we integrated with the CAD environment Rhino Grasshopper for our algorithmic design workflow. So then, so this data essentially started to talk to our other algorithms that were developed to generate the actual embodied forms of the controller. So essentially what we're talking about here is take bespoke data that's generated from the scanning rig, the biomechanical data. So this is specific ergonomic data. It isn't sort of general more general ergonomic data where you're talking about percentiles, with this aspect is designed for the 95th percentile male. It's not that kind of data at all. It's more highly attuned ergonomic data, so specific around an individual person. So the bespoke data goes into our algorithmic workflow, where we have a kind of macro stage algorithm that sort of blocks out the defines the larger structure, and then the micro algorithmic level that defines the small detailing, such as the mechanisms and the specific fit and that kind of thing. So this essentially generates a fairly bespoke design. So Yeah, to just go through these points, the algorithmic workflow allows for the consolidation of this ergonomic information, mapping it against other design constraints and design requirements. For example, the hardware requirements, functional, mechanical, componentry specifications as well. So, and by creating these abstract spatial envelopes which the controller forms could fill, the algorithms can take the unique user data and generate kind of optimized controller designs. Optimized, I mean, around the individual's anatomy, the individual's biomechanics, and the individual's ergonomics. So theoretically, the designs are optimized both around ergonomics and the functional requirements that have been defined in the constraints. So that's how these algorithms work. I mean, we define the sort of spatial aspects of the forms. What's roughly going to what roughly needs to happen in what spatial envelope, and then the algorithm builds in the forms around the information that we provide, such as what hardware needs to go where. So we have VR trackers that need to be placed in certain positions. So that information is already built into the algorithmic workflow as a as a kind of fundamental constraint in the system. So we have this kind of sort of advanced kind of ergonomic design that's taking in lots and lots of different types of information. So yeah, so combining the acquired data and the spatial definitions, forms such as this have been generated in our explorations. So I won't go into too much detail, but the scan data of a arm, wrist, and hand, and these controller configurations have been generated around this specific form. So, this wrist element here has been configured around the sort of spatial boundaries of the arm, and indeed this functional compliant mechanism hinge type structure here has been generated with relation to that and a functional goal of having the wrist be able to be flexible for the controller to function properly. And indeed, you can see here there's a VR track integrated into the design as well. So that taken together, this shows how you can generate specific bespoke forms for an individual person, and also have the hardware that's required for the device to function correctly, sort of in spatial terms. So yeah, just to go through these points, forms have been built to demonstrate specific anatomical data hardware structural requirements, and we Prime VR continues to develop these techniques, but the continued development of the bespoke controllers prove promising. So this is our as is Prime VR bespoke VR controller as it stands currently. So I can't go into too much detail about the design, but you can see here how a scan of the arm, the ergonomic information of the arm has allowed us to compare aspects of the design specifically around anatomical ergonomic elements. So we have these straps can wrap around the arm and the wrist, the hand, and indeed we have a spine element that can facilitate the complex motion of the arm in various ways. And obviously we have the integrated hardware of the the VR architecture that's required, the tracker parts, and so on. And this control is designed so that the wrist can move from a what's called a flexion to an extension motion. So kind of if you hold your hand flat, like moving it back and forward, that's the motion that the controller is designed to carry out. And then this motion is translated into specific functions within the game. And I mean, I'm not going to talk about that, but like what that shows is you have a completely different way of doing things. So we have this sort of very bespoke ergonomic design that also translates into a kind of slightly different functional approach to the whole system. So we have this motion that is designed to be therapeutic, but also it allows people to engage with the VR gaming system that we've developed with the project. So I can't actually see who's here, but I've got some discussion questions, and I mean, if anyone's up for discussing these, you can chime in. But like, if anyone here has familiarity with ergonomics of VR controllers, how would you approach the ergonomics of VR controllers? So if anyone's here, they can provide some opinions. Leaving the floor open. Well, I mean, I would say that we're obviously taking a a very specific approach, but in more general terms, ergonomics can be approached using available ergonomic data, which is I think still updated every year or two, and I mean you can also, I mean, I'm a big fan of prototyping and that kind of thing, and getting a handle on the physicality of forms by actually making things that you can give to potential users, which allows you to then get a handle on how people are interacting with the forms themselves, and you can make small alterations that allow it to be more comfortable for more people. This would be sort of a more general level ergonomic design, and we're talking about a sort of almost an inclusive design approach where we're trying to include a small group of people that won't necessarily be able to access VR in conventional ways. So another question I had: what are the key steps in building an ergonomic profile for users of VR? I mean, I actually don't have much experience in the design of VR controllers, and more generally. I mean, obviously, like, I'm working on this project dealing with a controller design, but like, building up an ergonomic profile is obviously part of how a VR company build their needs to build their designs up. I think there's critical steps that people can think about, such as I mentioned, prototyping earlier. But I mean, actual like examination of actual examination of the motions and interactions that people kind of want to do given a certain spatial arrangement of a controller. So what, in design terms, what are the affordances available to them spatially? So what do people feel like they want to gravitate towards? What feels natural? What feels comfortable in terms of what buttons to press and or joystick to interact with? And obviously we have the added complexity of this sort of spatial dimension of VR worlds, like how aligned is the representation of the controller to the actual controller, because obviously you have almost controller avatars in themselves. Like they have representations of the controller that can be quite different to what you're holding in your hand, and other times they can be exact representations. And it's just about understanding that relationship, that I would say are the key steps in building the ergonomic design. Like these complexities are are very important for the designer of a controller. So here's another question. So Prime VR exploring the use of 3D scanning and algorithmic design. Do you think these methods could or should be more widely utilized? Does anyone have any insights, any comments around that? I mean, I would say like the implementation of of such a system. I mean, it maybe should be more widely used, but the problem is essentially accessibility, capability. Essentially, like think about it in kind of strict economic terms, the kind of workflow of generating a bespoke design is like just way more expensive than the workflow of generating an ergonomic design that is that can be used by lots and lots of different people just straight off the bat, straight off the shelf. So I mean, I think there's lots of interesting work going on in developing controllers for those that previously like found the conventional or commercially available designs difficult to use for whatever reason. So you have lots of interesting work with people that don't have use of their hands, being able to like use controllers or use control systems designed around the mouth, using their mouth and tongue, that kind of thing. But also, as we're doing with Prime, using completely different motions, such as the arm motions and the hand motions. So if you don't have dexterous use of your hands and fingers, like you can reconfigure the design around a completely different motion. I think this opens up a new essentially a new way of thinking about control design, a new kind of paradigm whereby you don't just assume that people can adapt to the certain design. Like it could be a case that designs could be configured like perfectly around the individual user, so they could be customized around an individual user's hands and like where they want to place their fingers while using the controllers. I mean, I think that's an interesting question, but as I said, like the issue essentially is refining such a system that it could be kind of democratized and more widely more widely available, because at the moment such a system is quite quite complex and quite cumbersome in some ways, like, and it requires a lot of it requires quite a lot of investment, to set up the initial conditions whereby the ergonomic design can be fully realized. So, should it be more widely utilized? Yes, perhaps. Could it be? I mean, that's a bit more complicated because it relies on these economic kind of economic assumptions that are very, very difficult to actually know in advance and so on. So, final kind of discussion question. So, do you think algorithmic design is a useful way of exploring ergonomic requirements? If anyone would like to input on this, feel free. I mean, I would say that it's been very interesting using algorithmic design in this way. I mean, I'd personally I'd done bits and pieces of algorithmic design before, but I'd never used it in these sort of strict ergonomic terms, whereby we're taking specific scan data from an individual and then trying to implement that in an algorithmic design workflow. I mean, whether it's useful or not is a sort of another question, because come back to, or that it's a question that's a bit more complicated, because you come back to how good is the ergonomic data. I mean, we've had some issues with the granularity of the ergonomic data. Like, some of it's been adequate, but other times it's not so adequate. So it affects the overall it affects the workflow because the algorithm can't establish the spatial boundaries of the forms. So I think it can be extremely useful, can be an extremely useful way of exploring ergonomic design and ergonomic requirements. But question remains, like, where do you get your data from? That is the key problem. So we're getting our data from scans and motion capture and force assessment, and that's fine, but we have this issue of granularity. So I mean, the trouble is you need to establish a clear and reliable system of getting usable ergonomic data that can then be utilized within the generative design system. So if you have the viable usable data, you can consider, or you can generate lots and lots of different designs, because the spatial arrangements, the spatial boundaries, the functional requirements have all been strictly defined, and everything is working as one in a nice kind of dance. But if you have poorly defined spatial boundaries, that you get into all kinds of bother with the algorithmic workflow, which means that that good ergonomic design can fail, and you'll have to rely on sort of more traditional methods such as direct anatomical anthropometric measurement using various anthropometry tools. I mean, I didn't mention that earlier. This way of scanning the body is a kind of overhaul of traditional anthropometry, whereby you'd have an anthropometrist who would be trained to identify certain bones, certain ligaments, certain joints, that are then used as references to take measurements. So these and these references are slightly different with every single person. So anthropometry is actually quite a complicated a complicated method of measurement. It requires lots of skill. But scanning allows for a kind of overhaul of that in some ways, but we still have this problem with scanning, which is reference, in a word, because we don't know where. It's difficult to sometimes know where the exact position of a joint is, for instance. So as I said, we don't have the granularity for that just yet, and the intelligence that we're using can't quite deliver that those insights. But yeah, I would say it is useful, but it has its complexities, it has its limitations, and some ways. I don't know if anyone else has any thoughts. Oh, I mean, another question I was thinking about, what the future for VR controllers is. I mean, do you believe there is a possibility for widespread bespoke ergonomic design? I mean, I touched on this kind of bit earlier on, but I mean, I think there is a possibility for it. It's just a case of the kind of economic conditions, I suppose, in some ways. Is there an incentive for implementing these kinds of systems on a widespread basis? What are the issues and the complexities that that we need to think about here? I mean, I would say that VR controllers. I mean, in some ways, there's there's quite a lot of people experimenting with gesture control. So the kind of removal of a kind of embodied control system altogether, a physical object that you interact with, and it's just hand gestures that are detected by various sensors and so on. But I think more likely there will be some kind of embodiment in the future, going forward. I think they might get smaller. Obviously, we're seeing the kind of VR glove type designs making becoming more advanced, more sophisticated. And obviously they kind of open up ways of doing things as well. So I think there is scope for new and interesting forms of design and interaction with controllers, but whether whether these will be more tuned to ergonomics is a different question, and kind of relies on the kind of availability of other technological frameworks. You know, I think like our designs are relying a lot on 3D printing, and obviously 3D printing has become, you know, more widespread and democratized in the last sort of 10 years or so. But you know, I think still there are these limitations in using 3D printing. You know, I think a key one is obviously time for manufacture can be a bit problematic. Um, some for some assembly lines. But yeah, I think yeah, that's more or less what I think. So thanks anyone for listening. There'll be a recording of this coming out somewhere. So
Thank you very much, Felix.
thank you. Colin, how do I exit the
Green, I will take it back, no problem.
Okay, cool.
We'll take it back, no problem. Excellent, yeah, brilliant. Thank you very much, Felix. If anyone has any questions for Felix, he'll be in the room for a couple of minutes if you want to ask him face to face. Felix, if you want a private discussion room or if you want to speak off the main floor, you can go into our little breakout room to the side there, if you want to. Thank you all then for attending. Our next session, our next talk workshop session today is on 1:30 CET, so 1:30 CET back in this room again. So thank you all for coming.